So we're going to keep solving equations, but we're going to solve them with a graphing method. We're going to solve them, honestly, with the computer, with Desmos. Also, in the next couple minutes, you're going to sort of find the math teacher's best kept secret. Okay, this is really easy. Some students are like, man, why didn't you tell me that sooner? Well, it's not about telling you things so that you can just get answers. It's about helping you understand the math. And the math says that if you have an equation equal to 0, the x-intercepts are going to be the solutions. We almost want to put like an exclamation mark by that. That is going to be sort of the best kept secret. So this implies a graphing method. And what we'll find out is that we just need to graph it, and we need to look between 0 and 360. Once you're done jotting this down, I really encourage you to have a graphing tool, probably Desmos, if it's a computer, if it's on your phone. You can watch me, but you're going to get a little more out of this if you participate with the couple problems we do. So it looks like we can solve an equation by just graphing it. But we need to know what we're looking for and make sure that we understand that we're still coming up with angles. We're still coming up with angles. And you always want to make sure that your Desmos is working. We haven't used it in a little while. It's not bad to review that. Sine of x plus cosine of x equals 0. Now, it still looks like an equation. You know, it looks like something that, quite frankly, we might have solved in one of the various things we've done in the last 3 days. I don't know if you did this in your notes, or maybe you did it on those cards just on the weekend. But it still looks like an equation. So how do we graph it? Well, what you want to understand, and this is true not for today only, this is true for like all mathematics, that anytime you have expressions, or in this case an equation, you can actually say that one side of the equation is a graph. And so it's kind of like saying, when does the graph equal 0? Now, to say when does the graph equal 0 is really to say when do the y values equal 0. And that happens at an x-intercept. Okay, so the reason this is going to work is because you can think of this as a graph equal to 0. Now, there's not really a catch to this, but you want to make sure that, again, Desmos is doing what you want it to do. Remember, we always want to change it to degrees. It kind of defaults to radians, but you want to change it to degrees. Your x-axis, now, you can make your x-axis negative 360 to 360, but as you guys kind of get a little smarter and understand trigonometry and just get more comfortable, you know, I don't need to do negative 360 to 360, especially because my answers, if you remember, are only supposed to be from 0 to 360. So like I don't need to see like half of the wasted graph. I can go 0 to 360. I don't like starting at 0 though, because I don't see the y-axis. So again, I don't like starting at 0 because I want to see where the y-axis is. So I'm going to start at negative 90. You honestly can kind of type in any numbers you want. Now the y-axis, same thing. I mean, it looks like right now my computer says it's going from negative 7 to 7. I know there's a time where we went like -4 to 4. You can go -10 to 10. You just want to understand that the y values don't need to go like to 360. That would be like not the same idea. So usually we pick some y values that are within -10 to 10. Well, sine of x plus cosine of x. I can just type that. I can type y equals. I don't know if you've realized, but you don't have to type y equals. You can if you want. You get the same thing. Okay, now you get a graph that we would have talked about in the last chapter, but really today I'm just looking at the x-intercepts. Like, it's almost too easy. If you just move your cursor, it's already plotted the x-intercept. It already showed it. It looks like 135 gets the job done. 135 is an x-intercept. And then make sure you get all the x-intercepts, because out here to the right is 315. Like, it already shows those points. All you have to do is really just kind of scroll over them. So we have 135 and 315. As I said, it's almost too easy, but it's good math, because we're just saying, when does the graph equal 0, which means the x-intercepts, which means those are the solutions. Okay, I kind of feel like if there was one more thing we were going to do here, it's honestly not necessary. Okay, but I still want to show it to you, because without the graph, without the graph, we could solve this problem with algebra. And since you're going to have a mini check on this in a few moments, it might not be a bad idea to remember how to solve this with algebra. Okay, because you need one trig function. Now, one trig function can come from a careful division. And again, do you feel like that you've seen a problem like this? I kind of feel like that we've gone over this exact problem or something very similar to it, because if you divide by cosine, okay, now that's kind of like a tier 3 problem, like you have to do something fancy like that. But if you divide by cosine, you end up getting one trig function. You get tangent plus 1 equals 0. And then, of course, just to remind you of what you guys have done correctly, you can do the inverse of -1. I'm going to show you the answer. If you happen to be typing this in a calculator, you might be a little surprised. But I'm going to show you the answer, because if you do the inverse of -1, you get this number. Now, I say that you might be a little surprised because that's not either of the two answers that we just wrote down. But that's because it's the answer that is back here in the negative place. Okay? Are the answers wrong? No, they're just different. These we got by looking at the graph. This we got by using algebra. It turns out that it is on the graph. It's just backwards in the negative space. I guess the other thing I want to say is that part of this class is you need to show the work. So if I ask you to solve a problem with algebra, you have to show these steps, even though we get a different answer. Okay, but everything is correct. It's just different ways to come about it. Let's try another one with sort of this graphing method. This isn't, it's supposed to be pretty easy, but we still have to make sure that we're being careful about some little details. Here I have 2 cosine equals 5 tangent. 2 cosine equals 5 tangent. It's a small detail, but it's pretty important, right? The equation has to equal 0. Oh, okay, so I have to like rearrange it. Yeah, you have to rearrange it before you type it into Desmos. I hope you would subtract 5 tangent, or you could have subtracted 2 cosine. You could subtract either one of them to make the equation equal 0. But now that I've got 2 cosine minus 5 tangent, again, it's almost too easy, but make sure that it's working for you. And you're just looking at the x-intercepts. Notice that Desmos already gives you those x values. It already highlights those x values. So all you have to do is just really scroll over or hover over. So we get 20.535 and we get 159,465. If it's going to be a decimal like this, let's put it down to 3 decimal places, just because technically that's what's required to get your exact answer. So be exact, because you can be. One more. You try it. I don't know if there's something special about it, but obviously I want you to be able to do this on your own. So secant squared plus 1/2 tangent equals 1. If you're asked to use a graphing method, then all you have to do is get this equation set up and then type it into Desmos. Now, I did want to make sure you could get the squared to work. You can use the little keyboard that's you can pop up from the bottom, or you can use the caret top key. The caret top key is associated with the number 6 on the keypad, and that'll make an exponent. If you're having any issues just getting it typed in, just let me know. Make sure that you understand how it works. I will say nicely, be careful. Where are the x-intercepts? You don't want other points, just the x-intercepts. Remember, you want to make it equal 0. So there you go. Remember, you want to make it equal 0. So you'll have to subtract 1 from both sides. Also, don't forget your 1/2 that's in front of tangent. Make it either y equals, or don't put that at all. You don't need the y equals. So because we can use some technology, maybe the equations can get a little fancier, and maybe the x-intercepts, we need to just be a little more careful. Remember, for it to be an x-intercept, y equals 0. So I'm pointing at 0, 0, because y equals 0. It looks like 153 and a little change. 153 is going to make it equal 0, but you may have noticed that the point in the middle, y does not equal 0. So I hope you didn't write down 165. No, no, no to 165. 180. And then as I go out here to the right, make sure that you continue to grab appropriate values. Looks like 333, not the point in the middle, but then 360. So you just have to be a little careful about the x-intercepts. It's actually not every point that's kind of like pictured on the screen. What was that one again? 333.435. Okay. Okay, I mean, if this was a question on like a test or a quiz or something, you know, hey, there's 5 answers. I would expect and hope that you're finding all of them. Is there anything about this particular problem? Again, not every point is an answer. It appears that some of those points on there are just at the bottom of the graph. Sometimes Desmos will show you like a minimum. All right. It's not quite as, it doesn't quite intrigue your mind as much. It doesn't make you think as much. You're just really using some technology, but it's math. And the nice thing is that we have some technology that can allow us to solve problems in this manner.